Yes, class. So we are doing question number 1, which is Dirichlet's theorem. Okay, so Dirichlet's theorem we have done up to the value of. We are doing this by induction formula. Okay, induction means first we have to prove for n equal to 2 here. Why n equal to 2? Because it's a multiple integral. In multiple integral we have to prove from n equal to 2, then n equal to 3 we are proving at the moment. Then we will assume that if it is 2 for n, okay, value of n, then it must be 2. Okay, assuming that it is 2 for n, then we have to prove that it is 2 for n plus 1. And after that we will say that it is 2 for all the value of n. Okay, now we are doing this for n equal to 3. That means triple integral we are finding out. First integral we calculate, second integral, or I2 we calculated, which was this much, okay, which we have just written down as question number 1, equation number 1. Now we are proving that it is 2. This theorem is 2. Dirichlet's theorem is 2 for n equal to 3. That is integral for n equal to 3 or I3. I3 is equal to 0 to x1, because here we have taken what we have taken here. Here we have taken x1 plus x2 plus x3 is less than or equal to 1. Okay. Here if we take x1 0, then 0 to x1 is the first limit. 0 to 1 minus x1 for x2. Okay. x3 we have taken here. So for x3 it is 0 to 1 minus x1 minus x2. If x3 is to be calculated, then 1 minus x1 minus x2 is the limits for 0 to for x3 here. Then we integrated x3 up to this we have done. So x3 we integrated with respect to x3 here, this x3. Okay, so x3 with respect to x3 we integrated x3 raised power L3 minus 1, which is this much. This we have done in the first category. I mean, when we calculated in case of I2 that we calculated there, we showed there the process. Okay, the similar process is here. You have integrated with respect to x3 here. x3 raised power 1 L3 minus 1 is integrated. Then it will be added with plus 1 power. Then L3 is left over. Then we will divide it by L3. This is x3 whole power L3 divided by L3. Okay. Now power left over is L3 only. Divided by L3. Now substituting the limits 0 to 1 minus x1 minus x2. Now we have substituted here limits in place of x3. Now this L3 we have taken outside. This is 1 point L3. If we have taken outside 1 point L3. This is 0 to x1 limit, 0 to 1 minus x1 into this x1 raised power L minus 1, L1 minus 1, x2 raised power L2 minus 1, and this is x3 in place of x3, 1 minus x1 minus x2 we have substituted, and power is L3. Now, what we assume here, we have taken x3, x2, integrate with respect to x2, let me write here, okay. Integrate with respect to, this is with respect to x2. We assume putting x2 equal to 1 minus x1 into t. So this whole will be converted into x1 only. We have assumed x2 equal to, or putting x2 equal to 1 minus x1 into t. Other variable we have to replace in other values. This is t here. So dx2, therefore differentiating it with respect to t, we obtain dx2 here, dx2 equal to 1 minus x1 is now constant. With respect to t we are integrating, it will be dx2 upon dt equal to 1 minus x1. Take dt to that side, it will be dt there. Limits. Now for limits, when x2 is substituted 0, this 1 minus x1 and 0. 0 is the lower limit and upper limit is 1 minus x1. If I substitute x2 as 1 minus x1, which is the upper limit, 1 minus x1 here, so 1 minus x1 upon 1 minus x1 is equal to 1. T is equal to 1. For x2 equal to 1 minus x1, t is equal to 1. And for x2 equal to 0, we substitute 0 here, 0. So t equal to 0. x2 equal to 0, t equal to 0. Now limits, let me substitute this. This is nothing but 1 upon L3 span of integers 0 to x1, same limit. It is now 0 to 1, 0 to 1 for t. Now this is x1 here, x1 raised power L1 minus 1, x2 is to be replaced by 1 minus x1, so this is nothing but 1 minus x1 into t. Let me write here the limit L2 minus 1. This is L2 minus 1 upon x2. x2 in place of x2 we have substituted 1 minus x1 into t. Alright. Now this is next bracket. Now in this bracket, let me write this. Okay, the larger bracket. This is 1 minus x1 minus sign. In place of x2 we have to substitute 1 minus x1 into t. Okay, and this is whole power L3. Okay, into dx1 dx2. Now dx2 is, now let me rub this. What is dx1 as it is? dx2 is this much value. This is 1 minus x1 into dt. Sorry, into dt. Now, if I take 1 minus x1 to outcome, let me write it here. Let me write it here. What do we get here? Therefore, I3 is equal to 1 upon L3, 0 to x1. Okay, this is 0 to 1. Now this is x1 whole power L1 minus. Okay, in second bracket, in which 1 minus x1, 1 minus x1, 1 minus x1 to outcome, this is 1 minus x1. So if I take 1 minus x1 common throughout, what are the powers here? This is 1 minus x1 whole power L2 minus 1. Let me write here L2 minus 1. From this one, 1 minus x1, if I take out, L3 will be power plus L3. And this is 1 minus x1 also common. This is 1 power, so plus 1. Alright. Into this second bracket, let me write like this, this one. This is 1 minus t only, because now t left over. This whole power is L3. Okay, so this is L3 here. Now dx1 into dt only, because 1 minus x1 we have taken outside. So what do we get here? So there are two values here, x1 and t. So let me separate them and then finally write the value, what is the value of that. So this will give us, let me write 1 upon L3. Now this is, let me separate them. This is 0 to x1 limits. 0 to x1 here. Okay. And 0 to x1, and this is 0 to 1 for this value. Still we are keeping this 0 to x1 as sorry, this was 0 to x1 here, no problem. So this is x1 whole power L1 minus 1 into 1 minus x1 whole power, this value. Okay, this is L2 minus 1 plus 1 cancel out, this is only L2 plus L3. Okay, so L, this value, and this is L1 minus 1. And here 0 to 1, if I take 0 to 1, sorry, it start in the beginning, it was 0 to 1 only, not x1. Because for x1, if I put here, it is 0 to 1. Because when x1 is 0 and 0 to 1 here, we substitute. Sorry for this is not x1, but first is 0 to 1, then 0 to 1 minus x, 0 to 1 answer. 0 to 1, then 0 to 1 minus x1, and similarly here 0 to x1, and sorry, this is here 0 to x1. This we are writing. Okay, and this is dx1. Second part. So here I'm sorry, this is not x1 but 0 to 1, because initial value we substitute for x1 as 0 to 1, then 0 to 1 minus x1 that we have already replaced. Okay, so now this is 0 to 1 for t here. Now t is, this t here was there. This t was I'm sorry, here T is also there. T is for L2 minus 1. It was L2 minus 1, I'm sorry. L2 minus 1, this T was missing here. Because it was 1 minus H1 into T whole power L2 minus 1. This value, let me write again. This was T raised power L2 minus 1, the first one. L2 minus 1 into 1 minus T whole power L3 into dx1 into dt. This was there. This L2 minus 1 into 1 minus T whole power L3 into this is dt now, dx1 we have taken. So these two integrals we have separated. Okay, this is very systematic. If there is any mistake, it will just make it totally wrong. So this is how we have to keep in mind. Only this limit, I'm sorry, this is 0 to 1 limit in initial value. 0 to 1 x1, then x2 is 0 to 1 minus x1, and x3 is 0 to 1 minus x1 minus x2 that we take. Now this is what? This is 1 upon L3. Now here, this is beta, let me write here in terms of beta. This is L1 minus 1 plus 1, that means L1 only. This is only L1. Here it is L2 plus L3 plus 1, that means L2 plus L3 plus 1 beta into this. This is also beta L2 minus 1 plus 1, that means only L2. And this is L3 plus 1. Okay, this is in terms of beta function. So now we have to express this beta. What is this beta value? L3. Now this value is L1, L2 plus L3 plus 1. So this is gamma L1 in terms of gamma. This is L2 plus L3 plus 1. Same gamma we put. And this is gamma sum of these three. This is 1 plus L1 plus L2 plus L3. This we have done. We know from gamma function the beta. Since let me write here. Since beta mn is equal to gamma n divided by gamma m plus n. This is the formula here. Okay, but in this case, when we convert this, then we add 1. L1 plus minus 1 plus 1, that means only L1. And here L2 plus L3 plus 1 in terms of beta if we convert. But in this case, we just write whatever the value given to us. L1, gamma L2 plus L3 plus 1, L2 plus L3 plus 1 upon sum of these two. So L1 plus L2 plus L3, 1 plus. Okay, this is 1 plus L1 plus L2 plus L3 into this value now. This is gamma L2, this one, gamma L3 plus 1 divided by gamma 1 plus L2 plus L3. So this gamma 1 plus L2 plus L3 and this cancelled out. Okay, since this we have given the identity, the formula is like this beta function. Now this is the value here, gamma L1, gamma L2. What was this? This is nothing but L3 gamma L3, because this gamma L3 plus 1 is equal to L3 into gamma L3. That will have. Okay, so this L3 will be cancelled out now. What the final value? Let me write here. Okay, so this comes out to be. So this is equal to 1 upon L3 it was. From here it is gamma L1, gamma L2. Now this can be written as gamma L3 plus 1, written as L3 gamma L3, since gamma m plus 1 equal to m gamma m is the formula. This is the same value, gamma L3 plus 1 means L3 into gamma L3 divided by only this value, which is 1 plus L1 plus L2 plus L3. This L3 and this L3 cancel out, which is nothing but gamma L1, gamma L2, gamma L3 divided by gamma 1 plus L1 plus L2 plus L3. Okay, so this is just like this one. This is for 3. So L equal I n equal to 3. This is in for third integral, for integral 3. The value is 2. Okay, so this is the same thing we have obtained. This is second equation. If I take, let me write here I3 is equal to, let me write here. So I3 we have put, so I3 is equal to, let me write directly this value, gamma L1, gamma L2, gamma L3 divided by gamma 1 plus L1 plus L2 plus L3. Okay, this is equation number 2 we have put. Now we have to assume that it is 2 for, if it is 2 for n, we assume this, that it is 2 for n. Let us assume that it is 2 for, let us assume that the theorem is true for nth integral, that is, let me write here double integral, then we put here triple integral sign. Okay, this last nth integral. So what was this one? This is x1 raised to power L1 minus 1 into x2, second one, L2 minus 1, and so on. This is xn raised to power ln minus 1, sorry, in between minus 1, this is ln here, into dx1 dx2 dot dxn. Okay, this is equal to, this is given to us, this is that value, this is gamma L1, gamma L2, and so on, gamma Ln divided by gamma 1 plus L1 plus L2 plus and so on Ln, this is plus sign, plus Ln. So this we assume that this is true. Then it must be true for n is equal to n plus 1. So now we have to prove that this is true for n plus 1 also. Let us prove it for n plus 1. Now let us prove this for n plus 1. This is L3 we have just, okay, no need of writing this, but still we are writing, let me write 1 plus L1 plus L2 plus L3. Okay, now let us prove it for, okay, prove it for n equal to n plus 1th integral. Let us prove it for, let us prove it for n equal to n plus 1th integral, that is I n plus 1 is equal to, let me write here, this is second integral. If I write here, okay, this is x raised power x1 raised power, this is x1 L1 minus 1, x2 raised power L2 minus 1, okay, and so on, and this will be xn raised power Ln minus 1 into xn plus 1 Ln plus 1 minus 1, okay, into dx1 dx2 and so on dxn into dxn plus 1. This is what we have to prove for. Now this can be written as, how it can be written as, if I write this, this is 0 to 1 only, and in between we can write, so all these integrals we can write, and then only dx1 we can write here 0 to 1, because where x1 plus x2 plus x3 plus and so on plus xn plus xn plus 1 is also equal to 1. So initially for x1 it is 0 to 1 limits, 0 to 1 limits. This we are substituting here. Okay, so this will be, this can be written as x1 raised power L1 minus 1 in between this whole value from x2 to this whole can be written as from the previous example we write it down. So let me write that here. It will be gamma L2. Okay, it will be gamma L2, gamma L3. Okay, divided by and so on. Gamma L2, gamma L3 up to gamma Ln, gamma Ln plus 1 divided by 1 plus L2 plus L3 plus and so on, Ln plus Ln plus 1. Okay, into 1 minus x1 whole power, 1 minus x1 whole power, L2 plus L2, sorry, L3, L2 onwards, up to, here let me write it, Ln plus 1 into dx1 only. Now only dx1 is left over. Okay, so other values which are from dx2 to dxn, this whole value is from previous example we took this. So L2, gamma L2, gamma L3, gamma Ln, gamma Ln plus 1 divided by this value. Okay, so now this whole value, this one can be separated. So this whole equal to gamma L2, gamma L3 and so on, gamma Ln, gamma Ln plus 1 divided by this value. This is gamma 1 plus L2, L3 plus and so on. Let me write up to Ln plus 1. This is and so on, Ln plus Ln plus 1. Okay, this is this value we have taken out of the sign of integration. The sign of integration 0 to 1 here. X1 raised over L1 minus 1 into 1 minus x1. This we have proved just by taking third one. In third, when I3 we proved, then we proved that this value equal to this much. And in the last term, and the first term, this one, this is last limit nth xn plus 1 we have converted into 1 minus xn. Okay, so that is giving us this. Okay, and this whole power is L2 plus L3 plus and so on plus Ln plus Ln plus 1 into dx1 only. But what about this one? This we know from binomial, from beta function. So this beta function will give us, let me write here, this is gamma L2, gamma L3 and so on multiplication into gamma Ln, gamma Ln plus 1 divided by, this is 1 plus L2 plus L3 plus gamma, plus Ln plus Ln plus 1 into what about this one? This is nothing but this is beta. This value is beta L1 because L1 minus 1 plus 1, that means L1 only, comma. This is L2 plus L3 plus and so on up to Ln plus 1. Now if I open this beta function, then what is this value? Let me write it here. Finally, we get I n plus 1 is equal to this value. This is L2, gamma L3 and so on, gamma Ln, gamma Ln plus 1 divided by 1 plus L2 plus L3 plus and so on plus Ln plus Ln plus 1. This last one, this is step. Now this beta L1, that means this is nothing but gamma L1. Okay, and this value is L2 plus L3 plus L3 and so on. And this is, let me write gamma, L2 started from L2 plus L3 plus and so on up to Ln plus 1. We know that this is gamma, this gamma m, gamma L, gamma m into gamma n is this whole, gamma of this whole, of divided by gamma 1 plus L1 plus L2 plus L3 plus and so on up to Ln plus 1, complete value. Now what about this value? This and this one. Now this is this can be converted into this, but if I write this value, okay, and we write this one, this will give us okay, only this value upon this will come out, this L1 into L2, and this value will be cancelled out by this. I'm sorry, this value we have taken the denominator as how this is coming. So this value is 1 in this value into this. I'm sorry, this is coming to be, I think this 1 is not there in this case, because if, oh sorry, alright, this was here plus, I'm sorry, because B, whenever we find out beta, in case of this beta, this is 1 plus, I'm sorry, this is plus 1. When we write beta, in this case L1 minus 1 plus 1 we added, but here we didn't add. So here L2 plus L3 up to Ln plus Ln plus 1 must be there. I'm sorry, this is 1 plus L2 here. Now it's okay. Understood? Why? Because whenever we write beta, this converted into beta function, and in the powers we add 1 extra. This is L1 minus 1 plus 1, that means only L1. Here we have not added 1, but here we have to add 1. This is L2 plus L3 plus Ln plus 1 plus 1. So this 1 is beta, so this whole value is cancelled out. Alright. Therefore, this comes out to be the same answer is coming out. What is the final answer? Therefore, this gamma 1 L1, gamma L2, gamma L3, and so on, gamma Ln, gamma Ln plus 1 divided by this whole value, which is nothing but 1 plus L1 plus L2 plus L3 plus and so on up to Ln plus 1. Okay, so this is true for n plus 1. N plus 1 is 2. Hence it is true for, this implies that, it is true for n plus 1th integral. For n plus 1th integral, if it is true for nth integral, which we assume that nth integral is true, then it must be true for n plus 1th integral, so that we have proved here. Nth integral, okay, this we assumed. Therefore, this function is true for all values of n. We have proved that it is true for n equal to 2, n equal to 3, n equal to 4, and so on. This theorem is true. Hence, the theorem is true. Sorry. So the theorem is true. Dirichlet's theorem is true for all values of n, that is n equal to 2, 3, 4, and so on up to n. All values of n. It is true for all values of n. This is what we have to say. Dirichlet's theorem. This one is Dirichlet's theorem. These are known as Dirichlet's integrals. Dirichlet's integrals are very important in case of solving the multiple integral questions. Okay, so now let me take what is LOUISVILLE'S extension theorem of Dirichlet's theorem, because both were contemporary. They lived together, I mean in the same period. This means they share their knowledge. Then LOUISVILLE gave extension of Dirichlet's theorem, and this is in terms of question number 2, which I have taken here. Theorem, LOUISVILLE'S theorem. LOUISVILLE'S extension of Dirichlet's theorem. Second point is, question number 2 is LOUISVILLE'S extension of Dirichlet's theorem. Of Dirichlet's theorem. What is this second question? This question number second is LOUISVILLE'S theorem. This is or LOUISVILLE'S extension of Dirichlet's theorem. This question is. We have proved that this question is. If that is solution here, we are finding out what is given here. This theorem that we have to prove triple integral sign. This is f x plus y plus z into x raised power l minus 1, y raised power m minus 1, z raised power n minus 1 into dx d by dz. Okay, and this is equal to gamma l, gamma n divided by gamma l plus m plus n. Okay, h1 to h2 limits, and this is fh into h raised power l plus n minus 1 into dh. Okay, so this is known as extension of Dirichlet's theorem given by LOUISVILLE. Joseph LOUISVILLE, we have already explained about them, that who were Dirichlet's, who was LOUISVILLE. So Joseph LOUISVILLE gave this extension theorem of Dirichlet's theorem. Extend the Dirichlet's theorem. This is further extended. So let me prove this, that how this is proved here. Now let me take. Okay, if here we are given that x plus y plus z, h1, h2. Let if the x plus y plus z, these two values are less or equal to h, let me take, then the integral, what integral? This value. Okay, then this integral, because this is fx here, then the integral, let me write here, then the integral x raised power l minus 1, y raised power m minus 1, z raised power n minus 1 into dx dy dz. This is equal to how much? Nothing but this is, okay, gamma l, gamma n divided by gamma 1 plus l plus m plus n.